different edit. We'll have all of this stuff in our template. We just got to put in that last straight and total length and load position.
Yeah.
And even our template can have a standard load position. It may work with almost all your parts.
Yeah.
All right. That takes care of that screen. Let's look at the FPB. If I take this extended pipe length and move that into the tube total length, it'll calculate my bend start position. I may find that I have to go through all of them, but actually I do. This is 71.37.
Well, now all this makes me think I don't want to use a simulation because I have to key punch all the new stuff in anyway once it hits the bender. So if I'm going to have to enter that in anyway, I might as well use the offline programmer. So.
Oh wait, it had a bend start position. I was looking at the plain start position. I didn't have to type those 3 in again.
Okay.
Yeah. In fact, I need to change that back to 864.12. Notice it kept that value in the history.
Yeah,
that's something
that's
we
nice.
Pointed out. All right, R2. All those are R2. Then start position. I think that's not everything we need to make it run apart.
So
right.
And
hold on a second. So after you transfer the part from here to there, what?
I had to, after I transferred the part from here to there, I had to go in and, sorry, let's do it this way. I had to go in first to jig information.
Yeah.
Even though I didn't do it here, we did it physically. I can do it 2 ways, but I would recommend we go to jig information, enter the dimensions we measured.
Right.
Because then we go here, it's going to calculate those based on the jig information or the tooling dimensions, plus 10 millimeters excess space, and from probably most of your parts, that's 5.
Okay.
Yeah.
And we also have to put a radius value and a pipe supply position, and we had to make sure die change was checked to no. That's what we did on this screen.
So those are the 2 screens I told you earlier that no matter what we have to check and modify for each part. The work specification and the jig specification.
All right. And FPB, which I could have went right here, and I think I misled you. The only thing I need to do is drop that extended pipe length to the tube total length. Okay. And we would have a bend start position, which is where it needs to be for the first bend.
Okay.
And the only other thing we might need to do would go to this last straight, which is going to calculate this last feed. To get out of the way, it's calculated based on your last straight, but you need to change it, add more to it, because you're wanting the machine to get out of the way.
Right.
So
and that's one, if it's a 90-degree bend, probably put in the length of the pressure die. If it's a 180, you know the part's coming around, you might want to put more. And we're going to put, how many millimeters? I'm going to put 500. All right.
Okay, so that's the, you say it?
Yeah.
Okay, so those are so mainly we need to the work specification screen, the jig specification, we need to enter so that will, those 2 screens will calculate our collision bender, collision points, and then we have the tube total length, which is already there. We just need to move it from there to there, and then add a field here for how much we want the feed to move back.
Yeah.
Okay.
The rest of this will default. We default to in process 1, which will take both buttons.
Yeah.
Nothing set in avoidance moves unless it was set in the sim software.
The avoidance moves
are transferred.
Okay.
And that's where the sim software comes in handy.
Yeah.
But I'll be honest, on most of your 2 or 3 bin parts, you may consider it an extra bit of time that you don't need to use from something you can look at and figure out.
Right.
But if you're doing 6, 7, or 8 bin parts, now it may save you some time.
Right.
Because you may have to scrap 2 or 3 or 4 parts to be able to figure out what this is going to do in one part run with no scrap.
Mm-hmm.
Okay. So now we're pretty much ready to run.
Yeah. Now we're pretty much ready to run.
Okay.
In fact, we got that part appointed, so I'm going to bring up the motion monitor. We're going to power it up.
What part is that?
838500.
We have to, here it is.
Oh, thank you.
Alright. And the only thing we're going to do with this first run is we're going to stop it before it makes the first bend, measure the length of the first straight to see if it did the math properly.
Uh-huh.
That may be wrong if this tube length don't match the exact tube length I entered in the program.
Right, and a lot of times it doesn't.
Yeah, because your extended tube length calculated from your print probably doesn't match your cut length that you guys have determined over making the part.
Right.
When you found out it's stretched, you may have made it a little shorter. And if I had a tube stop, I'd be loading against a hard tube stop. Right now, I'm just guessing where it is. Let me get over here and actually make sure I lined it up exactly a millimeter behind that. Yes, it. Okay. Now, at this point, we put it in one stop.
Now, how would you set that program for gripper mode if after importing it? I didn't see that as an option in the settings.
Oh, I'm sorry, it was an option, but it's a little different than what you've seen before in the past.
Mm-hmm.
This bin method in sequence, that represents PF mode.
Okay.
And if I push that again, they'll change the GP.
Okay. Well, I guess it would change the load point and all that if you changed it to that now.
Yeah, if I well, I'm in auto mode, so it's not going to change this anyway.
Right.
Not unless I go to manual where I can save it. What I want to do now is step through the first pullback. That should be 0.88 hanging out. Oh no, that's not. No, that's what we. Okay, 0.88 is 2235. There we go. Thinking in inches again. No, I got 1274. It needs to be 2235. All right. This is something that has to do with why we got to measure your machine. Because we've got to set up the parameters in the system data, so then when it pulls back the values it calculates in your program, that value will equal a physical position that matches. What we're going to do now is we're going to move this physically to where 2235 is extended, and we're going to copy that as the bin start point, which is the same thing you do writing a new program on your odor bender. Yeah. Right there. Right. Pull it back just a little bit. Whoa. Okay, so there's your 22.35 millimeters hanging out.
You see, these are some of the things that the roamer, these are some of the corrections that the roamer will take care of.
Yeah.
You know, after you made your master in the roamer and you bend it, and then the roamer makes the correction between the master and the actual, those are the little values that are corrected by them.
Yeah. In fact, if the simulation software has produced a part, transferred the avoidance moves, your spring back in this one position is really the only errors you got to correct, and the roamer will do that with one run. I know the roamer will correct the aircraft tolerance in one run on stainless steel. They'll definitely correct to your tolerance on copper in one run.